Hi, I'm Shirin Shahana, student of 3rd semester MSc Chemistry from E-Content Development Center, Majlis Arts and Science College, Puramannur. Today, in this session, we are going to discuss about chemistry of polymerization. By the end of this session, you will be able to define what is functionality and what is chain polymerization. You can also list out different types of chain polymerization, and you will be able to define what is free radical polymerization, and you can write the mechanism of free radical polymerization. Let's get into the session. Functionality of monomer. For the formation of a polymer, a monomer molecule should react with at least two molecules of same kind or of different compounds. For this, a monomer molecule should contain at least two reactive sites. This number of reactive sites or functional group per molecule is named as functionality. The reactive functional groups can be hydroxyl group, acid group, amino group, thio group, cyanide group, etc. Chain polymerization. It is the self-addition of monomer molecule to each other very rapidly through chain reactions. It is also named as addition polymerization. There will be no byproduct during this polymerization. It is a greater advantage of this polymerization. If there will be no byproduct, it means there will be no chemical pollutant. Chain polymerization consists of three major steps: initiation, propagation, and termination. This polymerization can be brought about by three mechanisms: free radical polymerization, ionic polymerization, and coordination polymerization. Today, in this session, we are going to discuss only about the free radical polymerization. Initiation of free radical polymerization. As the name indicates, the initiation is brought about by the free radicals. These free radicals are produced from the decomposition of initiators. What are initiators? Initiators are the thermally unstable compounds which undergo decomposition by applying energy. We can apply energy such as heat energy, light energy, or even by using catalyst. Azo compounds, peroxides, hydroperoxides, peracids, and peresters can be used as initiators. If we apply energy to these initiators, it undergo homolytic decomposition or homolytic cleavage. Homolytic cleavage is a breakage of covalent bond in such a way that each unshared of electron will goes to each fragments. These fragments containing an unpaired of electron or a single electron is known as free radicals. Let's see the mechanism here. You can see an initiator undergo homolysis. Homolysis is a homolytic cleavage or homolytic decomposition. By applying heat, it becomes two free radicals. There is an example for this. It is a hydrogen peroxide on heating will yield two OH free radicals. Benzoyl peroxide. On applying heat to the benzoyl peroxide will yield two benzoyloxyl radical, and it will undergo further homolysis to yield phenyl radical and also carbon dioxide molecule. Homolysis of peracid will yield acetate radical, methyl radical, and hydroxyl radical. You may notice that the decomposition of single initiator will yield more than one type of free radicals. A free radical is highly reactive and always looking forward for an electron to be coupled with it. Hence, it can attack any molecule containing a lone pair of electron and a molecule with which it can take part one of its electron. The free radical will attack the double bond of a monomer. Here you can see this free electron of this radical will interfere with one of the pi electron of this bond, and they form a covalent bond between them. The remaining electron will remain as a free electron. You may also notice that there is a shift of radical site from the fragment radical to the monomer. And also you can see the shift of pi electrons to the sigma electrons. The coming down of electrons from pi level to sigma level is always accompanied with an energy release of 20 kilocalories. Hence, the free radical attack on the monomer is exothermic, while the formation of free radical from its initiator is endothermic. Propagation. In propagation step, the radical site at first monomer will attack the double bond of fresh second monomer and links this second monomer to the first monomer. Here you can see in this mechanism, the radical site is shifted from first monomer to second monomer. This chain again contains a free radical which can attack another fresh monomer, and this process continues. This successive addition of monomer units to the upgrowing chain is known as propagation. You can see the mechanism of propagation here. This free electron of second monomer will attack one of the pi electron of new monomer and yield another free radicals. The propagation lasts till the termination mechanism occurs. The entire structure of upgrowing chain can be represented either in this way. Here R CH2 CHX M times CH2 CHX. Here M represents the number of monomers. The mode of addition of monomer to the growing chain can be 4 types. Consider the monomer as CH2 double bond CHX. It is a vinyl monomer. Consider this as head of the monomer, while this portion is the tail of the monomer. If head of this monomer attaches to the tail of the upgrowing chain, it will be head to tail. In similar way, tail to tail, head to head, and tail to head. Each time a monomer unit is added to the upgrowing chain, the electrons comes from the higher pi level to lower sigma level, and there will be a release of energy of 20 kilocalories. Hence, there will be no requirement of any external source of energy for this propagation. This is a greater advantage of polymerization. The only energy required for this reaction is the small amount of energy that we apply to decompose the initiators to yield the free radicals. Termination. After propagation comes termination. Here the growth of chain will stop and the growth of polymer will be arrested. You may notice that the decomposition of a single initiator will produce many free radicals at the same time, and each one of these free radicals will be capable of initiating and propagating many chain reactions. There may be a large number of growing chain present in a system, and there is a probability of 2 growing chain come closer and collide each other. The growth of chain will be arrested here. This type of termination is called as termination by coupling. You can see the mechanism here. Consider the 2 growing chains here. You can see the free radicals. If they'll come closer, they'll form a covalent bond between them and form a product. It is a new polymer. And you may notice that there will be no free radical present in this polymer, which means this reaction is terminated. Termination by disproportionation. In this termination, hydrogen of one of a growing chain is being abstracted by another chain. We will look into the mechanism. Here, one of the hydrogen of one growing chain is being abstracted by another growing chain, and we get 2 polymers as products. N groups. Due to the termination reaction, the polymer molecule contains the molecules such as R CH2 double bond CHX at the 2 chain ends. Such groups are called N chains. Dead polymers. Dead polymer chain. The process of termination results in the deactivation of growing polymer chain. Such polymers are known as dead polymers. Termination by chain transfer. Here termination occurs by the transfer reaction. When growth of one polymer chain is stopped, the formation of a new free radical is generated simultaneously, and this free radical will be capable of initiating and propagating a new polymer chain. Here, a hydrogen atom can be abstracted from initiators, monomers, polymers, or any other species present in the system, such as impurity and solvents. You can see the termination here. Here this chain abstracts an hydrogen from this molecule and become the product. You can see this chain is being terminated, and at the same time this molecule has become a new free radical, and this free radical can initiate and propagate a new chain reaction. Here you may notice that termination of one chain and initiation of a new one takes place simultaneously. And you may also notice the transfer of chain growth from one side to another. This transfer is known as chain transfer. Hope you all understood the session. Thank you.